It began like any other Thursday. The city stirred to life, people rushing to catch trains, the hum of daily routines filling the air. No one suspected that today would be different, that history was quietly waiting to unfold. Until the world stopped for a NASA and ESA press conference. Screens everywhere flickered with urgency, and the usual chatter faded as the world tuned in, united by curiosity and a hint of unease. Speculation ran wild, but no one was prepared for the truth. Social media buzzed with theories, some wild, some hopeful, but nothing could have readied us for what was about to be revealed. Dr. Evelyn Reed, lead exoplanetologist, stepped to the podium and declared, "We are not alone." The silence was global. The news spread instantly, echoing through every home, every street, every heart. For a moment, the world held its breath. This wasn't a fuzzy signal or a fluke. It was the culmination of years of tireless research, checked and rechecked by the brightest minds on Earth. It was clear, undeniable data from a rocky world 500 light-years away. The numbers, the patterns, all pointed to one conclusion: something extraordinary was out there. For the first time, we had proof. Life exists beyond Earth. Tears of joy and disbelief mingled as people everywhere tried to grasp the enormity of the moment. On screens worldwide, an artist's rendering of Kepler 186f became the face of a new reality. The image, both alien and familiar, sparked imaginations and ignited hope. Strangers hugged in city squares. Barriers of language and culture melted away, replaced by a shared sense of wonder and connection. Classrooms paused to watch history. Children and teachers alike stared in awe, realizing their textbooks would never be the same. The endless noise of daily life faded, replaced by a single, unifying conversation. For once, the world spoke with one voice, asking the same questions, dreaming the same dreams. Humanity's oldest question, "Is anybody out there?" was answered. Generations of wonder, of searching the stars, had finally led to this moment. The confirmation wasn't a fleet of ships but a scientific whisper from across space, a faint, persistent signal carrying the story of another world. Kepler 186f, orbiting a dim red star, was breathing. Its atmosphere pulsed with the unmistakable signs of life, a cosmic heartbeat echoing across the void. The evidence, spikes on a graph, a spectral analysis of its atmosphere. Oxygen, methane, and other gases danced in patterns that could only mean one thing: life. Those lines of data were the most revolutionary text ever written, the chemical signature of a living world. Scientists wept, knowing they had glimpsed the handwriting of the universe itself. The universe suddenly felt less empty. Billions of stars, once cold and distant, now seemed alive with possibility. Our existence felt part of a grand cosmic story. Families gathered, friends called each other, and strangers shared a silent understanding: we are not alone. The age of cosmic loneliness was over. A new chapter had begun, one filled with hope, curiosity, and the promise of connection. The age of discovery had just begun. Humanity looked up, ready to explore, to learn, and to reach out across the stars, knowing at last that someone might be listening. The revelation of life beyond Earth shattered invisible walls in our collective psyche. Suddenly, the questions we'd asked for centuries, are we alone? What is our place in the universe? Were no longer abstract. They became real, urgent, and deeply personal. For a moment, borders and politics seemed trivial. The lines we'd drawn on maps, the disputes that had divided us, all faded into insignificance beneath the vastness of the cosmos. We were Earthlings, united by a shared cosmic identity, no longer just citizens of nations but members of a single fragile world, spinning together through the darkness. It was a moment of humility and awe. Tears welled in eyes not from fear, but from the overwhelming beauty and mystery of what lay beyond. We realized we weren't the center of the universe but part of something bigger. Our planet, once the stage for all our dramas, was now just one world among countless others. The universe wasn't ours to conquer, but a vast library we'd just begun to read. Each discovery was a new page, each question a chapter waiting to be explored. People gathered, not to protest or celebrate but to look up at the night sky together. In parks, on rooftops, and in open fields, strangers became companions, united by wonder. Kepler 186f's faint red star became a beacon of hope. Its distant glow reminded us that the universe was alive with possibilities and that we were not alone in our longing to connect. The discovery didn't solve our problems, but it gave us perspective. Old arguments seemed smaller, and new dreams began to take root in the fertile soil of our imaginations. We are all crew members on Spaceship Earth, navigating a much larger cosmos. Our differences, once sources of conflict, now seemed like the colors of a single beautiful tapestry. Arguments over trivial matters faded in the face of this truth. Under the stars, we remembered what truly mattered: connection, curiosity, and hope. The confirmation of life was not an endpoint, but a challenge: to be better, to think bigger, and to act as one people under a billion stars. It was a call to protect our world and to reach out, together, into the unknown. The journey had only just begun. With every sunrise we stepped forward, not just as individuals but as a united species, humbled and inspired by the infinite sky above. The hero of this story is the James Webb Space Telescope, humanity's greatest eye, a marvel of engineering and imagination that has redefined how we see the cosmos. It stands as a testament to decades of collaboration, innovation, and the relentless human drive to explore the unknown. Launched in 2021 after years of anticipation, JWST now orbits 1 million miles from Earth, far beyond the reach of our planet's shadow. Shielded from the sun by a massive tennis court-sized sunshield, it operates in the cold darkness, perfectly positioned at the Lagrange point, to observe the universe without interference. Unlike any telescope before it, JWST sees in infrared, detecting faint heat signatures from the farthest reaches of the cosmos. This unique vision allows it to peer through clouds of dust and gas, revealing secrets that have been hidden for billions of years. Its gold-coated mirror, made up of 18 hexagonal segments, unfolds delicately in space, gathering ancient photons that have traveled across unimaginable distances. Each segment works in perfect harmony, creating a giant light bucket that captures the faintest glimmers from the dawn of time. This extraordinary sensitivity means JWST could spot the heat of a single bumblebee on the surface of the moon, an astonishing feat that highlights just how powerful this instrument truly is. But JWST isn't just about capturing beautiful images. It peers through cosmic dust to witness the birth of the very first galaxies, and it analyzes the atmospheres of distant exoplanets, searching for signs of life and the building blocks of habitability. In many ways, it's both a time machine and a cosmic laboratory, allowing us to look back over 13 billion years and study the universe as it was in its infancy. With every observation, JWST reveals the universe in ways we never imagined possible. With JWST, we can finally read the chemical stories written in the atmospheres of distant worlds, decoding the fingerprints of water, carbon, and other vital elements that may hint at life beyond Earth. It's the tool that made this discovery possible, empowering scientists around the globe to unlock mysteries that have puzzled humanity for generations. Thanks to the James Webb Space Telescope, the universe has never looked closer, or more full of wonder and possibility. Detecting life 500 light-years away sounds impossible, but scientists use transit spectroscopy. When Kepler 186f passes in front of its star, a fraction of starlight filters through its atmosphere. JWST captures this filtered light, revealing a chemical fingerprint. Different gases absorb specific wavelengths, leaving unique barcodes in the spectrum. The telescope's spectrographs split the starlight, mapping dark lines where gases absorb light. By stacking data from dozens of transits, scientists built a clear signal. They searched for a cocktail of gases: water, carbon dioxide, methane, and oxygen, that together point to life. Finding all four is the smoking gun. It's painstaking work, but the result is undeniable. We read the breath of a distant world. Why Kepler 186f? Discovered in 2014, it was the first Earth-sized planet in the habitable zone of another star. The habitable zone is the Goldilocks region, just right for liquid water. Kepler 186fe is about 10% larger than Earth, likely rocky, orbiting a cool red dwarf. Its year lasts 130 days, and its surface glows in perpetual sunset. Life there would adapt to dim reddish light. Plants might be black or deep red. The star is old and stable, making life more likely. These traits made Kepler 186f a top target for JWST. On August 14, 2025, the bet paid off. Earth's cousin was alive. The search for life had found its first success. Kepler 186f's status as a living world came from four gases, biosignatures in its atmosphere. First, water vapor, the solvent of life. Second, carbon dioxide, key to a working carbon cycle. Third, methane, which must be constantly replenished on Earth, mostly by life. The clincher was oxygen, a reactive gas that shouldn't persist unless something is making it. On Earth, that's photosynthesis. Finding oxygen and methane together, two gases that destroy each other, was the knockout blow. This chemical disequilibrium is the fingerprint of a living planet. The evidence was overwhelming. Kepler 186f wasn't just habitable, it was inhabited. The universe had spoken. Why does this mix of gases mean life? It's about thermodynamic disequilibrium. Imagine a lit candle, it can't last forever unless someone keeps lighting it. On Kepler 186f, oxygen and methane coexist, even though they should react and vanish. Something must be constantly producing both. On Earth, that's biology. Photosynthetic life makes oxygen, microbes make methane. Scientists tried every non-biological explanation, volcanoes, strange chemistry, but nothing fit. Only a biosphere could maintain this unstable mix. The data didn't just suggest life, it demanded it. Kepler 186f's atmosphere was the signature of a global metabolism. The planet was breathing. This wasn't just about molecules, it was about a living process on a planetary scale. The discovery was rigorous, not wishful thinking. For the first time, we'd found a world alive. For millennia, our cosmic address was lonely. Third planet from the Sun, in a seemingly empty universe. The discovery of life on Kepler 186f changed that. We're now part of a cosmic neighborhood, even if our nearest neighbor is 500 light-years away. We're not special because we're alone, but because we're aware. Our intelligence and curiosity are our unique contributions. The universe is not just rocks and gas, it's creative, perhaps even biased toward life. This realization reframes our responsibility to Earth. Our planet is now a specimen, a Rosetta Stone for understanding life everywhere. Environmental challenges are threats to our cosmic heritage. We are custodians of one of the universe's precious gardens. The discovery makes our own world feel even more sacred. The confirmation of life on Kepler 186f is just the beginning. The new questions: how common is life? Is it like us? Is there intelligence? Space agencies are planning new telescopes and even interstellar probes. The discovery is a call to action for everyone, to be curious, to look up, to learn. The universe is more mysterious and wonderful than we imagined. The explorers who will answer these questions are in our classrooms now. We must inspire them to dream big and chase answers. Next time you look at the night sky, remember it's not empty. We are part of a living universe. The greatest adventures are still ahead.